Question 8. A uniform rod of length L is pivoted at one of its end on a vertical shaft of negligible radius. When the shaft rotates at an angular speed omega, the rod makes an angle theta with it. To find theta, equate the rate of change of angular momentum, which would be ml square by 12 into omega square sine theta cos theta about the center of mass, to the torque provided by the horizontal and vertical forces Fh and Fv about the center of mass. So we have to find the value of theta. Okay, as we can see that in this given figure, that they both that Fv and H both are perpendicular to each other. Okay, and mg is perpendicular to omega square by 2 into sine theta, and we as we know that force is equal to m into g, so uh, we would sim we would simply substitute the value of g which would be omega square into L by 2 sine theta. So as we know that the torque net about the center of mass is Fv into L by 2 sine theta minus Fh into L by 2 cos theta. So and we would simplify this, and we would get ml square by 12 into omega square sine theta cos theta. Now we would simplify this equation. Okay, and we would simplify this by using differentiation again and again, and in the end we would find the value of cos theta, which would be 3g by 2 omega square L.